My name is Neeraj Lamsal. Today I am making my one of my first video on monotonic stack. This is one of algorithms that you can use uh, to solve problems in an efficient way, like problems related to finding the previous smallest element, next smallest element, and next greater element, and previous greater element. This type of things can be uh, solved using monotonic stack. So before getting into solving, let's understand what monotonic stack really is. A monotonic stack is a stack in which the elements are strictly increasing or in decreasing order. So uh, based on that, there are two types of monotonic stack. One is monotonic increasing or and monotonic decreasing. So the key idea in this type of stack is that we should maintain order while adding or removing elements efficiently. So let me give you some example with a simple array. Let's say we have an array of 5, 3, 4, 1, and 6. And let's say I have to make a monotonic stack that is increasing. Okay, increasing. So we will first traverse left to right of the array. uh, uh, I'm specifically traveling left to right, but you can also travel right to left. It depends on what you want to do, but for simplicity I will just traverse left to right of an array. Okay. uh, so is everyone should know this. This is index 0, this is index 1, index 2, 3, and 4. uh, this makes us easier to map the things in the array. Okay. Let's say we are at index I equals to 0. First of all, we know that the stack is empty, so whatever is the first element that we shall just push it. So 5, right? Okay. Now we are at index 1. The element that we need to push is uh, element that we need to push is 3, but the thing we have in the stack is 5. So do you think it is appropriate to add 3? It is not, because you can already see that we want an increasing stack, but this is going to a decreasing stack, so I will just erase it. Okay. So uh, the action the main action that we have to perform is in this case, like suppose here we have to maintain the order, but here the next element is not maintaining the order. So this is the main idea, like this is the part where we need to do certain things that helps us solve the problem. So you will later find out in one of our next video, like how this helps us to solve problem like previous greater element, finding the largest rectangle in a histogram, that kind of problem related to monotonic stack. So now what should we do? uh, we should just pop the element so that we can maintain the order. So sorry, just erase it. And I will just pop it, the head, that means the head of the stack, I will just pop it. Okay. The thing is that we usually push the index and compare the index to the top of the stack, but here I am directly pushing the element so that it is easier to visualize. But later in the video I will also show you how we will push the index of the stack and how we will do that while we code, but not here. Okay. So after popping the stack is empty, right? So we have nothing, so we will just push the element that is 3 to the stack. So it's a 3. Okay, now the stack is already in a like neutral order. It is not like increasing because we have only one element, so we can't say anything, but we want to make it increasing. We know that. Okay, so I equals to 2, and the element next we want to process is 4. Okay, now the stack here, we the stack before processing 4 is 3. So do you think we can just proceed the number 4? The thing we will here see is we want the top of the stack to be always less than the next element that the index we are in. That means the top of the stacks will be always be smaller than the current index that we are currently in. Okay, so you can see that this currently satisfy what we want. So I will just push it to the stack. So that means push for, okay, to the stack that we had made. So 3 and 4. Okay, now let's go to index number 3, and the element we are processing for the element number I equals to 3 equals 1. Okay, and the stack before doing anything, h 3 and 4. Now as I told you, we want the stack to be in increasing order, so it will be inappropriate for us to push 1, because it will obviously uh, make the it won't make it like in an increasing order. You know what I'm trying to say, right? Okay, let's erase it. And now, so the thing is, first of all, I will pop the head of the stack. Okay, because one is we know that we want element that is greater than the top of the stack. So but one is smaller, so we will just pop it, and we have 3, right? Now we will again check. So we want the we are at current index I equals to 3, but we want that index to be greater than the top of the stack. But the top of the stack is 3, but we want it to be smaller than 1. So like, so we can't do nothing, we just need to pop it. You know what I'm trying to say? So um uh, as I will repeat, we want the top of the stack to be greater, okay, than the current index, but it is impossible to make it, so we will just pop it. So we will again pop it, and now the stack is empty. Okay, we can stack is empty. I will just don't write anything, so we can't do anything. Okay, and the stack is empty. Now it's time to push this element. So here it, I just hate it. Okay, so just push element number 1. Now okay, we are at our final index, that is I equals to 4, and the element we are processing currently h6. So before processing anything, the stack that we currently have is 1, and we will check that the current index that we are in, that is I equals to 4, will be greater than top of the stack. So this satisfies the condition, so we don't need to think anything, we will just push it. Okay, 1 6. So this is the final form of stack that we will achieve uh, while making this increasing stack. Okay, this is for increasing stack. Let me also show you how decreasing stack is made. The concept is similar, but we just need to make it in a decreasing way. Let me write the array for easiness here. 5 3 4 1 and 6, and I equals to 0, 1, 2, 3, and 4. Okay, and also we want to make stack decreasing here. I feel like it will be much easier because the number are perfectly arranged for that. And we will traverse left to right of the array. So uh let's again start making stack. So we are at currently in the at index I equals to 0, so there is nothing. So we will just push the first element that I equals to 0, so we will just push 3. And now that we will come at I equals to 1, right? And now the element that we are processing for each at the index is number 3 and 5. So now we want to make it decreasing. That means the top element should be smaller. So is the element 3 smaller than 5? Yes, it is. So you don't need to think anything. So just push it, okay? So push 3, 5, and now 3. Now that is for I equals to 1. Let's jump into I equals to 1, 2. So the element that we are processing currently is 4. So the stack before doing anything in this index is 5 and then 3. So as I told you, we want the elements to be in decreasing order, like 5, 3, 2. Okay, so the current index should be always be smaller, but you can already see that the current index is bigger than the top of the stack, so stack order won't remain, so we need to pop it. So let's pop the first element 5, and we will pop it. Okay, so I have already popped it, so let me erase it, pop it. Okay, now we will again compare. Is 4 smaller than 5? It is, so we can add it. This helps us retain the decreasing property of the stack. I feel like you should get intuition now what we are trying to achieve in this process. 5, 4. Okay, now this is for index I equals 2. Now let's go to I equals to 3, and the element that we are processing is element equals to 1. The stack that we have before doing anything else in this index is 5 and then 4. Okay, now we need to check that is that this element 1 is smaller than the top of the 4. It is, so we don't need to worry about anything, just push it, man. It's 5, 4, and that 1. Okay, this is the stack order that we have in final form. Now we are in the final index, and we have the element that we need to process each 6, and the stack that we currently have is 5, 4, and 1. Okay, now we need to check that the current index that we are in at 4, we have element 6. Is the element 6 smaller than 1? It is not. Element 6 is always greater than 1, so we will just pop it, pop the head. Okay, when I said pop, we are popping the top of the stack, not head. So sorry for my language. And 5 and 4. Okay, now again we will check, it's 6 smaller than 4? No. Then again pop it. Now we're at 5. Okay, it's 6 smaller than 5? No. Again. So as you can see that we got an empty stack. Now we can't do anything. We just need to push 6. So or we can't like say like it is increasing or decreasing, but this is not violating the condition of a decreasing stack, or element. If we have only one element, we can either say it is increasing or decreasing, because it is not violating the property of increasing or decreasing, but neither it is showing the property of increasing and decreasing. Like this is like a neutral situation. Okay. This that's it for this video. In the next video, we will solve some problem, and I will the thing you if you can see this popping thing. Okay, this is the, as I have told you multiple times, this is the right time when we do the action that is asked in the question, like this point, and also this point, this point. So sorry, let me not do this. Okay, this point, this point, this point, this is the exact point that we need to do something in the stack that helps us solve the problem. This point, this point, this point, this point. Okay, we will see much in the later video. Thank you for watching, and this is my first video that I have made just for uh, so that I can help us improve my learning and also help some other people to learn as well. Thank you so much for watching. If you have been in the full, if you have been looking the full video, thank you.